Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P16BB, indicates an issue with the alternator B terminal circuit, specifically low voltage detection. This code is relevant for Honda Fit models manufactured between 2015 and 2020. The alternator plays a crucial role in charging the vehicle's battery and supplying power to electrical systems while the engine is running. The B terminal of the alternator is primarily responsible for ensuring that adequate voltage is supplied to power these systems, and any faults here can lead to a variety of electrical malfunctions. Recognizing this issue promptly is essential for maintaining vehicle reliability and performance. The P16BB DTC indicates a low voltage condition in the alternator's B terminal circuit. The primary component involved in this diagnostic trouble code is the alternator, which is critical for charging the vehicle's 12-volt battery and supplying power to electrical components. Located in the engine compartment, the alternator converts mechanical energy from the engine into electrical energy. Its B terminal connects directly to the battery terminal fuse box, ensuring that power is delivered effectively. A failure or issue in this circuit can lead to inadequate charging of the battery and potential electrical failures. The fault might be intermittent and would typically trigger a warning light on the dashboard or other electrical anomalies. Several factors could lead to the P16BB code being triggered in your Honda Fit. Firstly, poor connections at the alternator and the battery terminal fuse box can disrupt the voltage supply. Secondly, if the terminals are loose, this may also contribute to a low voltage condition. Additionally, there may be an open wire between the alternator and the battery terminal fuse box, preventing proper current flow. Moreover, the performance of the 12-volt battery is crucial. If the battery shows signs of weak performance, it may falsely trigger this DTC. Each of these potential causes needs to be verified to accurately diagnose the issue affecting the alternator circuit. The symptoms associated with DTC P16BB can manifest in several ways. One primary indicator is the illumination of warning lights on the dashboard, specifically the battery or electrical system warning light. Electrical system failures can be observed, such as malfunctioning accessories or lights that flicker. Additionally, drivers may notice dimming headlights, particularly when other electrical components are engaged, which points to insufficient voltage supply. Another common issue is difficulty starting the vehicle, as the battery may not receive adequate charge from the alternator. Recognizing these symptoms is essential for taking timely action to prevent further electrical failures. The first step in troubleshooting DTC P16BB involves verifying the problem by initializing the vehicle systems. Start by turning the ignition to the on mode, which powers up the vehicle's electronics without starting the engine. Next, utilize the Honda Diagnostic System HDS tool to clear any existing DTCs that might interfere with your diagnosis. After clearing the codes, start the engine and ensure all electrical loads are engaged. This includes turning on the air conditioning, setting the temperature control to maximum cool, setting the blower fan to maximum speed, turning on high beam headlights, and activating the rear window defogger. It's essential to monitor these conditions while holding the engine speed at 2000 RPM without any load for 1 minute. Finally, after that minute, check for any pending or confirmed DTCs using the HDS tool. If P16BB appears again, proceed to the next troubleshooting step. Step 2 of the troubleshooting process focuses on examining the connections related to the alternator. Inspect for any poor connections or loose terminals, specifically at the alternator and the battery terminal fuse box, where the +B line connects. Loose or corroded connections can significantly affect the electrical flow and may be the root cause of the P16BB code. If the connections are found to be faulty in any way, they should be repaired to ensure a solid electrical contact. After addressing any issues with the connections, you will want to move on to the third step to conduct a more thorough check of the wiring harness to ensure that it is intact and operational. In the third troubleshooting step for DTC P16BB, the focus turns to verifying the integrity of the wiring, specifically looking for an open wire between the alternator and the battery terminal fuse box. This check is crucial because any interruption in this wire can cause a significant voltage drop, leading to the DTC being triggered. Carefully inspect the entire engine harness for signs of damage or wear, as these could lead to an open circuit. If the wire between the alternator and the battery terminal fuse box is identified as intact, it indicates that the alternator may be faulty. In such a scenario, replacing the alternator should be your next course of action to resolve the low voltage issue and restore proper function to the electrical systems. After completing the necessary repairs for DTC P16BB, verification of the repairs is the next crucial step. Begin by using the HDS to clear the previously stored DTCs so that any new fault codes can be accurately monitored. Once the codes are cleared, test the vehicle under normal operating conditions to ensure that everything operates smoothly. During this test, closely observe the electrical system and verify that the alternator is now functioning correctly without triggering the P16BB code. It's important to monitor the vehicle's performance closely in the days following the repairs to confirm that the problem has been resolved and does not reoccur. Successful verification is essential for customer satisfaction and vehicle reliability. To prevent issues similar to DTC P16BB in the future, preventive maintenance is essential. Regular inspections of the alternator and the battery terminal connections can identify potential issues before they become significant problems. Keeping these connections clean and free of corrosion is vital to ensuring the electrical system operates effectively. It's also crucial to routinely check the condition of the battery. A healthy battery is critical for optimal performance. Lastly, inspecting the wiring harness for damage or wear and performing necessary services will help maintain a dependable electrical system. Following these preventive measures will enhance the longevity of the vehicle's electrical components and ensure reliable operation. In conclusion, addressing DTC P16BB requires a systematic approach to troubleshooting and repair. First, confirming the presence of the DTC is essential for understanding the scope of the issue. Thoroughly checking the connections at the alternator and the battery terminal fuse box is paramount, as loose or corroded connections frequently cause low voltage conditions. Additionally, testing the integrity of the wiring between these components must be conducted to rule out any open circuits. Performing upgrades and regular maintenance can also greatly contribute to avoiding similar issues in the future. By adhering to the provided guidelines and maintaining the vehicle's electrical system properly, you can ensure the longevity and reliability of your Honda Fit. Please like and subscribe to the channel. See you next time.